Hi there. In this section, you are going to learn about the theorems of limits. So let's begin. Theorems of limits. Let's consider the first theorem. So the theorem 1 is for any positive integer n, limit x tends to a, x to the power n minus a to the power n over x minus a is equal to n a to the power n minus 1. Now let's consider an example to understand this theorem. So the example is find limit x tends to 2, x cubed minus 8 over x minus 2. So what I'm going to do, I'm going to consider this limit and then I will consider that limit and convert it in this form. So as you can see, it is given that limit x tends to 2, x cubed minus 8 over x minus 2, and I'm going to rewrite that one so that that fits in this form. So if I do that, I will write limit x tends to 2, x cubed minus 2 cubed over x minus 2, because 8 is basically 2 cubed, and that's what I have done over here. Now let's use this theorem. So as you can see, my n is 3 and my a is 2. So I'm going to use this formula n a to the power n minus 1. So I will write 3 times a, which is 2 to the power 3 minus 1, because my n is 3. So 3 minus 1 is 2. So I will write 3 times 2 to the power 2, and 2 to the power 2 is 4. So I will write 3 times 4. So 3 times 4 is 12. So basically the value of this limit is 12. Now let's consider the next theorem. So the theorem 2. If f and g are two functions such that fx is less than or equal to gx, and limit x tends to a fx and limit x tends to a gx is defined, then what I'm going to do, I'm going to take limit on both sides of this inequality, and if I do that, I will write limit x tends to a fx is less than or equal to limit x tends to a gx. And as you can see, this theorem satisfies, or I should say this limit will satisfy, because limit x tends to a fx and limit x tends to a gx exists, or you can say they are defined. Now let's consider our next theorem. Theorem 3. Limit x tends to 0, sine x over x is equal to 1. Now let's consider theorem 4. Theorem 4. Limit x tends to 0, 1 minus cosine x over x is equal to 0.